Hello there everyone. This is our second lesson going over properties of exponents. Last time we went over multiplication properties of exponents. If you need help with that, go find that video on our channel. Today we're going to be going over division properties of exponents. And by the end of this lesson, you should be able to use these division properties to simplify your expressions. So this is just a quick recap. If you want a lot of the basics, that was in our first lesson. But we're basically just mentioning here, previously you did addition and subtraction problems where you combined like terms, but the exponents didn't change, like in this example. It's still squared the entire way through. But in our future problems, exponents are changing. So now we're going to be going over how these division terms affect the exponents. So the first term that we're going to be going over is quotient of powers. It states that when dividing terms with the same base, the exponents are subtracted. Here is what it will look like on your formula sheet. A to the power of m divided by a to the power of n is the same thing as saying a to the power of m minus n. So the numerator's exponent minus the denominator's exponent. So knowing that, why does this make sense? You have x to the power of 6 divided by x to the power of 4 equals x to the power of 2. Well, if we use the power that we just saw, we can rewrite this as x6 over x4 becomes x6 minus 4, which then gives us that x squared. Now, we can look at another example of this. Here we're simplifying y to the power of 7 divided by y to the power of 3. Once again, we can rewrite this same as it's shown in the steps over here. So we can say, okay, we already have the first part written out. This will become y to the power of 7 minus 3, which will become y to the power of 4. You're just subtracting the denominator's exponent from the numerator's exponent, or doing numerator exponent minus denominator exponent. So here you're doing 7 minus 3 to get that 4. Here is another example that we can use. This one brings in our coefficients, which are just our normal numbers that are attached to the variable. Once again, if you saw in our last lesson, remember that the coefficients and the variables with the exponents follow different rules. Coefficients follow normal rules, the normal mathematical processes you learned in like 2nd, 3rd, 4th grade. The exponents are the only ones that follow their own special rules. Even if the coefficients are attached, they still don't follow the same rules as the things with the actual exponents. So here, as it states in this step, you want to separate the coefficients and variables because we're doing different things for both of them. So first let's find our coefficients. They're the normal numbers. So we just see, okay, 4 and 2. So we have our 4 over our 2. Now let's find our variables with the exponents. It's just what's left here. It's the x to the power of 5 over x to the power of 2. So, once again, what we're doing with the coefficients is just what you normally do when you divide. So here, you just do, this becomes 4 divided by 2. Technically, you don't have to write this out because these are the exact same thing, but I just wanted to show that this fraction still just stays as normal division. So in this case, it's just 2. It's just normal division. Isn't that easy? Now, for this one here, we're using those special rules again. We're bringing the x, and then we're doing the numerator's exponent, taking the minus sign, and then the denominator's exponent. So 5 minus 2, which will then give us x to the power of 3. Now, Whenever you have multiple terms and you found out what each one is, you just slap them together. So here, you just take these, you take the coefficient, start with coefficient, because remember it goes in front, and then we take our other value, x squared. And we're left with our final answer as 2x to the power of 3. So now that we've done a little bit of practice, you can do an independent question on your own. So take a moment, read this problem, read the question, read the answer choices, pause the video, work this out on your own, and see if you can figure out which answer choice is correct. I'll give you a moment. Now in this case, the correct answer choice should be C. I'll go ahead and explain why. So, once again, we're doing our normal exponential division rule, as in there's nothing special about this problem, we're still just subtracting the exponents. So we can take our R values, R8 over R3, and we do, once again, just take that variable, do the denominator exponent minus, or the numerator exponent, sorry, minus the denominator exponent. And you subtract them, and you get R to the power of 5. We can do the same thing with the S. So we do S to the power of 5 over S to the power of 2. That turns into, you take the S, you do 5 minus 2, and you're left with S to the power of 3. As always, once you're done, you take those values that you found and you mesh them together. So you start with the R value, because it goes first in this case, and then the S value. And then you're left with your answer of R to the power of 5, S to the power of 3, or known as C in this case. Here's another example that you can do on your own. So once again, pause the video and work this out yourself. Now, for this one, the correct answer choice would be D. And here's why. Well, once again, we're doing what we've always been doing. First of all, this one has coefficients. So let's separate those first. You have 12 and you have 4. So 12 over 4, or 12 divided by 4, still follows the normal process, so you're going to get 3. Now we can do each of the variable with exponent values. So we do the A6 over A2 to get A6 minus 2 to get A to the power 4. We can now move on to the B values. So we have, I will work over here now, just so there's much space. B to the power of 5 over B. Remember, whenever something doesn't show an exponent, that is the same thing as saying it's an exponent of 1. Because by saying exponent of 1, you're just saying that the number is there. So in this case, it's 5 minus 1, which is what gives you that B to the power of 4. Last one we're doing is C values. So we do C4 over C3 to get C4 minus 3 for powers. And then you're just left with C1, or, because once again, it's the same with an exponent of 1 as with no exponent, so it's C to the power 1 or C. So now we have everything that we need. Just highlight all the values that you got and mesh them all together at the very end. So we have that 3, the coefficient, and the A value, then the B value, and then the C value. So at the end, you're left with 3, A to the power 4, B to the power 4, C, or the answer choice, D. Now let's move on to our next rule, power of a quotient. It states that when dividing terms raised to a power, you can raise each term to that power and then divide. If you remember our power of a power rule, I believe it was called, from the last lesson, you know that it works a lot like the distribution that was there. These are both like distributive properties, okay? It's basically, this one is basically saying that when you have a fraction in a parentheses and then you have the n value, the n is distributed to every value in those parentheses in both of the fraction values. It's essentially the same thing as just saying distributive property, but for exponents. So we can use this one as an example of this. This one, it's basically saying, once again, distribute it. Distribute it to the numerator and distribute it to the denominator. So we can go, and in this case, multiply this, because it follows, once again, this power of a power rule. You're going to multiply them. So you're going to multiply the numerators. M 4 times 2 over n 3 times 2 to get m to the power of 8 over n to the power of 6. That's going to be your answer for here. So here's a quick important break for the order of operations of exponents. So most exponent property problems, you'll have to do more than one property. And when you need to do this, you're supposed to use the properties in a specific order to make sure that you get the correct answer. First, simplify any expressions within the parentheses. Then use the power rules, power rule, power of product, power of quotient, those are all examples. And then use your multiplication and division rules. You can think about this a lot like PEMDAS. PEMDAS, which states that parentheses go first, then exponents, then multiplication or division, and then addition or subtraction. It's essentially saying the same thing, except for here it's just saying that the effects will be multiplication or division, and here the effects will be addition or subtraction. So think about it like parentheses first, then anything that causes you to multiply or divide exponents, and then anything that causes you to add or subtract exponents. With that being said, we can use this problem as a good example. Here, once again, we're starting off with those parentheses. So first of all, we're going to distribute. This is going to be distributed to remember every value, including our coefficients. So, let's start off with those coefficients. 2 to the power of 3 will give you, let me write this better, 2 to the power of 3 will give you 8, because 2 times 2, 4, and then times 2, 8. 4 to the power of 3, 4 times 4 is 16, times another 4 is 64. Now let's do those s values, s3 and s2. So s to the power of 3, and then also to the power of 3, means that you multiply the two exponents together, so you're left with s to the power of 9. We can do the same thing with s to the power of 2, s to the power of 2, and then to the power of 3 gives you s to the power 6. Now we're doing those t values. Here it's t4 to the power of 3 to give you t12, along with t3 to the power of 3 to give you t to the power of 9. Now that we have everything that we need written out, we can just put them together based on where they're supposed to be in the problem. So remember, we have our 2 became an 8. Let me write this down here rather. We have our 2 that became an 8. S3 became S9. And T4 became T12. Our 4 became a 64. S2 became S6. And T3 became T9. 9. Now, we're not quite done just yet, because we still have to do our quotient of powers rule. These can be further simplified. Now we want to subtract all of these, subtract from them. So, when we do 8 over 64, we can actually simplify that using a GCF, or greatest common factor, of 8. Because 8 is divisible by 8, and 64 is divisible by 8. So when you divide both of those by 8, you get 1 over 8. Now, you have S9 over S6. Remember, we're doing subtraction for that. Numerator's exponent minus denominator's exponent. So that turns into S9 minus 6, which turns into S to the power of 3. Same thing for T. T12 over T9 turns into T12 minus 9. Give us that T to the power of 3. This you can also rewrite, because these values, S to the power of 3 and T to the power of 3, are the same thing as being in the numerator, because they're, just whole values. Because you can imagine writing this as writing it over 1, which is why you can say that they're in the numerator. So this answer could also be written as S3 T3 over 8. And there's a good chance that'll be what you see as an answer choice instead. So there's a good example of how you use those order of operations together. Now here's an independent practice that you can do on your own, okay? This will be our last problem. So pause the video, work this out, see if you can figure out what to do. Okay, so if you pause the video and work this out, you should have gotten an answer choice of C. I will quickly explain why. So the numerator is the only one that we're distributing anything to, because a parentheses is not, it's not like this. It's not also including the denominator. It is just including the numerator. So we do all of these to the power of 3. 2 to the power of 3 becomes 8, same as the last problem. X to the power of 3, that turns into x 2 times 3, to give you x to the power of 6. Y to the power of 3 and then to the power of 3 is the same thing as y 3 times 3, so it's y to the power of 9. Once again, it only applies to the numerator, so keep the denominator the same. Now, we do the same thing with dividing, doing that quotient of powers rule, as you can see right here. So, dividing each of these, we are doing 8 divided by 4, just normal division, so you get, or not 8 divided by 4, 8 divided by 2, and it's just normal division, so you just get 4. Now we're doing x6 over x2, which turns into x6 minus 2, to give you that x to the power of 4. And then the y values have y9 over y4, which turns into y9 minus 4, to give you y to the power of 3. We have everything that we need now, and we just slap it all together. Get the final answer of 4, x to the power of 4, y to the power of 5. Or answer choice C. Okay, and that will be the end of this video. It still turned out a little bit long, but it's definitely shorter than the other one. So here's a quick summary of what we went over, and important things to remember. Remember to separate the coefficients and the variables. Exponent rules only apply to the variable terms. The coefficient rules just have your normal mathematical rules, so be careful that you're using the right rules for the right values. When working with more than one property, remember to use order of operations, both PEMDAS for the normal numbers and the exponential equivalent of PEMDAS. Without further ado, I do hope this helped. Our next video in this like lesson unit sort of should be special properties of exponents. You should see it up if it's been uploaded already. I hope this helps you guys in some sort of way. And I hope everyone has a lovely day. I just made the same rhyme as I did last video. Interesting. Alright, but have a nice day, everyone.